Example 4 wants us, this is from section 2.5, example 4 wants us to look at the limit as h approaches 5. So if the limit as h approaches 5 of h minus 5, all that divided by the square root of h plus 4, and then that minus 3. So if we try to put 5 in the top, 5 minus 5 is 0. If we put 5 down here, 5 plus 4 is 9. Square root of 9 is 3. 3 minus 3 is 0. We are in form 0 over 0. So hopefully we can do something to this to get things to cancel out nicely. When you see square root stuff with a minus in it, usually that's gonna, or a lot of times you can fix that with the conjugate. So we're gonna try to do let's see here, h minus 5, all that over square root of h plus 4 minus 3. We're going to multiply the top and the bottom by square root of h plus 4 plus 3. And we'll have that on the top and the bottom. So really what we're multiplying that fraction out there by is 1. So it's still the same thing as this, but we've kind of changed the form without changing the information. The one that has just, it looks the same, but the sign is different, is the one I'll FOIL out, and the top part I'll leave kind of alone. So I'm going to leave it as it's two things multiplied together, but not actually do the multiplication on that. The bottom one, however, we will FOIL that out. So we'll get h square root of h plus 4 times itself will be square root of h plus 4 squared. The outer will be a square root of h plus 4 plus a 3, or times a 3. Square root of h plus 4. The inner will be negative 3 times the square root of h plus 4. And the last will be a negative 3 times a positive 3, which is a negative 9. So, let's see here. Let's rewrite the top part. Now, a square root will cancel a square, or a square will cancel a square root. So I'll be left with an h plus 4 down here. The 3 square roots of h plus 4 minus the 3 square roots of h plus 4. We have positive 3 of those, minus 3. Those will cancel. And we'll get left with a negative 9. So we get h minus 5 times the square root of h plus 4 plus a 3. All that over h plus 4 minus 9 is, well, plus 4 minus 9 is minus 5. And we'll notice that the h minus 5s can cancel, which means our original statement is equal to the square root of h plus 4 plus 3, as long as h is not 5. Well, 5 is where we were looking at the limit, so we're looking at the limit as h equals 5, so we're looking at numbers close to 5 without actually being 5. So our original form, the limit, will equal this. So we'll write that out and we'll say, all right, well, the original limit we were curious about, limit as h approaches 5 of h minus 5, all that over square root of h plus 4. What was it, minus 3? That is equal to the limit as h approaches 5 of square root of h plus 4 plus 3. And now this right here, we should note, that is continuous at 5. Because h plus 4 is continuous, the composition of a continuous function with a continuous function is continuous, and adding 3 is still continuous. So this right here is continuous at x equals 5. We could also say it's an elementary function. and therefore we can evaluate it by substituting the 5 in and get the square root of 5 plus 4 plus 3. Square root of 5 plus 4 is 9, square root of 9 is 3, so this is 3 plus 3, which will end up equaling 6. Okay, and that should do that one.